So sorry. So I didn't record last week, so I need to redo those. Bless you. So when I showed you the shortcut for metric only, and that was this stair step right here. Going down, you move to the right, going up, you move to the left, however many steps you take. That should only be used to check it. Can you see that okay, or is it? Okay, wow. With these glasses, there's no way I'm gonna. All right, we'll have to fix that. We'll definitely fix that. We'll get back to, is that light? Because she's using it from the top and that's why it's smaller. So we'll have to go back to the other way. But for today, we'll have to, let me see, sorry guys, let me see if I can make it bigger. Oh, there we go. Okay. All right, I'll do that for today. So this stair step method is only to be used to check your unit conversions, because what I want you to do is I want you to be able to set up your unit conversions like we did over here, right? The number given over 1, and then you set up your unit multiplier, and then you cross cancel to make sure that what's left is the correct one. So the reason for that is because what we're going to do today, we cannot just move a decimal right and left. What we're going to do today is work on the what they call the imperial system, or the, let me get to the right one, or the US measures. So to yards, to inches, to gallons, to quarts, to pints, all of those unit measures that we use. Okay, so this page is in your notebook. It's page 45. That you should have flagged. So if you have a little, there's those sticky ones that you can flag it, because you're going to use that on your homework and on your test. So you don't have to have anything memorized. Everything you do, let me get this bigger. Everything you do is going to be right here. So you don't have to memorize the unit conversions. All you have to have is this sheet, and then know that you can set it up either way. Either, like the 1 inch to, 2.54 centimeters. You can have it as 1 over 2.5 or 2.5 over 1. They equal the same thing. All of these unit conversions equal 1. All right, so it's going to be super important that you can set up your unit conversions. So what we're going to do is take a look at just some preview stuff. So remember, if you're going from, the big over here. If we're going from 3 feet and you're taking it to inches, okay, so our unit of measure is 12 inches equals 1 foot. Okay, that's our unit conversion. So, so what we're doing is we're going from feet to inches. So again, we're going to set up our first number over 1. And then make sure that you're setting up your unit conversion, right? The unit that you're changing, what you're changing it from goes on the bottom. What you're changing it to goes on the top. All right, now again, notice I'm not putting any numbers in. No numbers until I know for sure that I can cross cancel and what I want should be on the top. If it's not, then you have to make some adjustments. But once you can cross cancel and know that what you're changing it to goes on top, then you know your numbers are going to be in the right spot. So it's 12 inches to 1 foot. Okay, now I know all I have to do is just multiply straight across. So 3 times 12 is 36. 1 times 1 is 1, so it's 36 inches. And then make sure that you get in the habit of always putting in the unit of measure. All right. Now, this is the easy one, right? This is easy. It's just 1 unit conversion. The reason why this whole cross canceling is so important is because we can have up to 12, 16 units of measure that we're converting. And you have no idea if it's set up correctly until you do that cross canceling idea. Okay, so don't get lazy on me. Make sure that you are taking the correct process. Okay. All right. So what we're going to do is, if we're looking at area, so these are kind of some applications. If we're looking at area, okay, so we're looking at area. And again, area of any rectangle is length times width. So here's our width, here's our length. So our area is 5 feet. And this little 1 tick mark is the symbol for feet, times 6 feet. Okay, so what you end up with is 30. And then because you have feet times feet, that is feet squared. So you really have to pay attention to the units of measure. So especially with area, because you're multiplying feet times feet, it's feet squared. So where that comes from is when I divide this up, and we're going to pretend that I'm doing this in 5 equal slices, and then we divide this up into 6 equal slices. Those are straight lines, not curved. If I counted every one of these squares, I would have 30 feet squared. I would have 30 squares. And that's where the feet squared comes in. So anytime you see something squared, that is area. Whatever the unit of measure is always its area. And 2 means it's 2-dimensional. That means it's on a flat surface. Okay, so now if I wanted you to change 30 feet squared to inches squared, now is where you are going to use your dimensional analysis. Yes, so Daniel asked, feet times feet will always have a squared solution. Yes, that's true. And if it was, Daniel, if it was feet times feet times feet, that would be feet cubed. So it goes back to that idea of exponents. If you're multiplying the same unit of measure by itself, you multiply it twice, that means it's going to have an exponent of 2. Okay, so here we go. So 30 feet times feet. Now I'm going to write it out like this, just so you can see why I do the unit of measure twice. So again, I want feet gone, and I'm changing it to inches. But if you notice, if I were to go through that and cancel, I'd only cancel 1. So I have to do it again. I have to do the exact same thing twice. And so now I can cancel the second one. And what I end up with is inches squared, which is what I want. So now I know I have the right things canceled, and now I can plug in my numbers. So it's going to be 30 times 12 times 12. Let me get out those calculators. So we have 4,000 inches. So 4,320 inches squared. 4,320 inches squared. And again, In order to get inches squared, I have to have two sets of unit multipliers. So I have to have 2 inches or inch by inch. Okay, so this formula right here, definitely keep this in mind. That is the formula for area of a rectangle. And you can also use that for area of a square too, same thing. Where did I get the 12? Oh, so Jade, the 12 comes from this unit of measure. Where'd it go? Oh, I thought I wrote it. I must have moved it. Is 12 inches is the same as 1 foot. So if you go back to your reference page, it's right here. 1 foot is the same as 12 inches. So that's where you're going to use your reference page. So keep that. You can even pull that out of your notebook and keep that to the side as you're working. Okay, good question. All right. So now we have volume. Okay, so volume of any rectangular solid is length times width times height. So length, width, and height. So if you have the volume of this cube is 2 feet by 2 feet by 2 feet. So 2 times 2 times 2 is 8. And feet times feet times feet, that gives us feet cubed. So if you have anything cubed, that equals volume, which means it's 3-dimensional. Try to write bigger. Okay, so the cube, the exponent 3 means you're looking at a 3-dimensional figure. It's got length, it's got width, it's got height. Okay, so now we want to change it to cubic inches. So we have 8 feet cubed, and we're changing that into inches cubed or cubic inches. So we're going to set up our unit multiplier. So what is given always over 1. So because I have feet cubed, that means I have to have 3 feet on the bottom, right? Because I want to eliminate 1, 2, 3. And then what I'm going to is inches on the top. Okay, so I double check. Can I cancel? So I have 3 of these. I have 1, 2, 3. What I have left is 3 inches multiplied. So that's inches cubed. So now I can plug in my numbers. So 12 inches to 1 foot, 12 inches to 1 foot, and 12 inches to 1 foot using your reference sheet. Okay, so 8 times 12 times 12 times 12. Or if you use your calculator, you can do it this way, 8 times 12 cubed. So on your calculator, right above on so I'm looking at the TI 30XS. Right on the first column, there's a hat. Looks like a hat, like that upside down V. This means exponent. So if you want to learn to use your calculator correctly, that's your exponent key. So what I did is I did 8 and then times, I'm going to use a dot for times, and then I did 12 hat 3. And I get 13824 inches cubed. Okay, or you can do 8 times 12 times 12 times 12. That works too, but if you want a shortcut. Okay. So any questions so far? And going over the metric and being able to set up with unit multipliers first really, really, really helps. Okay, so 37, here's your another just reference sheet, so you can use this too. This one does not have metric only, so you can use either one. So this one, what we're going to do, all right, we can just talk about this. You don't have to fill this in. So an inch, an example of an inch would be like a worm. A yard, what would be an example of a yard? Like, what would you look at that you would think, oh, that's about a yard? Baby blanket, perfect. What else? So how many feet in a yard? 3 feet in a yard. So about the height of the table would be another one. About the width of the table would be another one. What about a mile? Way too far to run. Do not like to run. So the way that I remember miles is, have you ever seen the movie Remember the Titans? Oh, love that movie. So he's mad. It's Denzel Washington. He's mad at Petey because Petey he wanted water, and he makes him run a mile, and he throws the football down and he goes, you're going to run 5,280 feet, which is a mile. You're killing me, Petey. I love that movie. It's a great movie. Okay, a quart. What would you like? What would be a quart in your mind? A what? Yeah. Yeah. Lemonade, a quart of lemonade, a quart of milk, quart of half and half. What about an ounce? Yeah. Medicine. Good. So you have a little eyedropper. So an ounce is not very much. And then an acre. An acre is a very big amount of room to have to weed whack. One time my oldest son got in bad trouble, bad trouble. He and his buddy decided to break windows out of old cars that were on somebody's property. And they were just sitting there. So in his mind, they were just old, not valuable. So he had to hand weed whack our entire acre with like a sickle. He had to swing it all summer long. He never did that again. we saved the sickle for him. Okay, we're gonna keep going. All right, so here we go. So have your reference sheet out. So I'm going to take mine out so I can refer to it. And what did I say it was? Oh, page 45. Now, when we're doing this, sometimes we're going to go from the US system to metric system. Sometimes we're going to go from metric to US. Sometimes we're going to go from, metric to metric and US to US. So just be aware of what units of measure we're looking at. So look on number 4, look at your conversion sheet. And I'm always going to write them down so that you have a reference for it. So you always look to see, okay, I'm going from inches to centimeters. So look at your reference, understand what each unit of measure is measuring. So if you look at inches and you look at centimeters, you're looking at length or distance. So that kind of narrows down where you're looking in your reference sheet. So it is 1 inch is the same as 2.54 centimeters. Okay. So for those of you going into any medical areas, radiology, nursing, whatever it is, you're going to have to do this because the baby is born. How big is my baby? And they say however many centimeters. You have to be able to translate that to the parents of, oh, they're 21 inches. Okay, so it's going to be real important. Now, obviously, when you're in the medical field, there are shortcuts. So, and I don't know all of them, but I know that they do use technology to do this. But you may have to do it on the fly and you don't have your technology with you. So always good to know how to do this quickly. Okay, so here we go. 21.5 inches over 1. We're taking away the inches, so it goes on the bottom, and we're changing it to centimeters. So it goes on top. And then always, always, always just make yourself double check. Inches goes away. Centimeters is what I want. So I know I have it set up correctly. Now, obviously, you're going to get much faster at this. But as you're practicing it, make yourself walk through these steps. So it's 1 inch to 2.54 centimeters. Okay, now I'm going to show you something because this is it's a common mistake. They do this because they're reading this, right? 1 inch to 2.54 centimeters. Always double check that your numbers are in the right spot. It's actually 2.54 centimeters to every 1 inch. So you want to make sure that your numbers are in the right spot. It's an easy mistake to make. So always look at your numbers again and make sure that they match. Okay, so now using your calculator, you're going to go 21.5 times 2 point, oops, helps to turn it on, 21.5 times 2.54. And you get 54.61 centimeters. Okay, so baby comes out, they do the measure, they say it's 54.61 centimeters. You have to quickly change it to inches, okay, which means you would just go in the opposite direction. Okay. All right, next one. We're going from meters to yards. So first thing I want you to do, you know you're looking at length. So on your chart, there is no unit of measure that takes you from meters to yards, not directly. So that means you have to find a pattern. So here's how I describe this. So there's different paths that you can take, all right? When I go to SeaWorld, I go, okay, I want to go to, you know, the orca show. So I can go to the left and go around, or I can go to the right and go around, or I can go straight through, right? It's just what's the best path, or what's the path of least resistance. So with unit multipliers, when there's more than one step, you just use the path of least resistance. Now you can go all over the place and then get back to yards and still get the same answer. But what's the path of least resistance? What's the straightest path that you can go? So what I would do is, we know we have meters to feet. It's 1 foot to 0.3048 meters. So let me write that one down. So 1 foot is 0.3048 meters. So I know I have meters, I'm good. Now I have feet and I have feet and yards. So if you go up 2, you can see it's 1 yard is 3 feet. 1 yard equals 3 feet. Now you have a path. Okay. Now you could have gone meters to centimeters, centimeters to inches, and then inches to feet and feet to yard. But you can see that's what, 4 different unit multipliers. So you would get the same answer, but you are just taking way more steps than you need. So it's just a matter of being able to find the units of measure that you need and taking the path of least resistance. So here we go. 120 meters over 1. So I'm going to use my 1 foot to 0.3048 meters. So meters is on bottom, feet is on top. And again, notice I'm not putting any numbers in yet. And then I'm going to get rid of feet and have yards on the top. So my meters goes away, my feet goes away, and all I have left is yards, and that's what I want. Okay, so now that I know I've got everything canceled, now I can plug in my numbers. So it's 1 foot to 0.3048 meters and 1 yard to 3 feet. Okay, so now the easiest way to do this is multiply straight across. So I have 120 times 1 times 1. And I have 0.3048 times 3 on the bottom. And this is in yards. So this is where it's really important to use your parentheses if you're using the calculator. So 120 divided by, and then parentheses, 0.3048 times 3, and then close parentheses. So it equals 131.233596 yards. Okay, so if you're using a calculator, I did it this way, 120 divided by, and then I did a parenthesis, 0.3048 times 3, and then closed parenthesis. So what that tells the calculator is this 120 is divided by this whole thing. If I don't put the parentheses in there, if I take the parentheses out, your calculator is going to read it as 120 divided by 0.3048, and then that answer times 3. So that's why you have to put in and tell the calculator, I'm dividing the 120 by that whole thing on the bottom. All right, any questions, comments, confusions? Probably the biggest complaint that I've heard of these is knowing which path to take. That's usually the biggest frustration, is I don't know which path to take. The general consensus is look at what you're given and where you're going, and then look at your reference sheet and see, okay, do I have the right process? All right, number 6, 55 miles. I'm going to go ahead and let you guys figure out which path you're going to take. So we're going from miles to meters. And again, we're looking at distance, so length. So you're going miles to meters. So anyone have an idea of which path you're going to take? Okay. So Jonathan said miles to feet and feet to meters. Did anyone have a different path? Everyone had the same one? Okay. So here's a different one, just to throw it out there. Someone could have went miles to kilometers and then kilometers to meters. So remember, you have those unit conversions also from kilometers to meters. So both of those have 2 paths. You'll get the exact same answer either one. So we'll go, you said miles. Oh no, you went meters to foot, right? So just so you know, that 0.3048, it's 3 feet, 3 inches in a meter. So it's just over a third. 1 foot is a third of a meter, if that helps. And then feet to miles. Okay, so here's my unit conversion setup. Feet to miles, because miles is on the bottom. Feet or meters to feet, because feet is on the bottom, and what I want is my meters. So I know I've set them up right. So 5,280 feet to 1 mile and 0.3048 meters to every 1 foot. So it's going to be 55 times 5,280 times 0.3048. So 88,513.92 meters. And remember, in math, it should be logical. It should make sense. So if you have 55 miles and you took out a meter stick and you measured the meter stick for 55 miles, you could tell, okay, I have to move that meter stick 88,513 times. And that's a 992. Okay, everyone good? Now, one thing that I want you to realize is you guys have seen this before. So now you're seeing it a second time, which is awesome because now it should start making more and more and more sense to you. All right, so here we go. Inches squared to centimeters squared. So the good news is we have one unit multiplier that is inches to centimeters, but because of the 2, we got to do it twice. So it's 1 inch is the same as 2.54 centimeters, but because it's inches squared, we have to do this twice. An inch, 2.54, double check. Both of those are going away, and what I want is centimeters squared. All right, so we've done lots of measuring or length. Now let's jump to gallons. So when you look at your reference sheet, you see volumes. When we're looking at volume or gallons and ounces, we're looking at volume. So we have 102 gallons and we're changing it to ounces. So look down, and this one is where it's going to be, we're going to have to take a few different steps because you can see we have gallons to quarts, quarts to pints, pints to ounces, pints to cup, cup to ounces, and cup to tablespoon. So you have a couple different units that you can use. You can go gallons to pints and pints to ounces, or you can do gallons. Did I say pints? I meant quarts. Gallons to quarts, quarts to pints, pints to ounces. Or you can do gallon to quart, quart to pint, pint to cup, cup to ounces. So you have a couple different options. So which one you want to use? And then quarts to what? Pints, okay. And then pints to ounces. Okay, so here we go. So we're going to do 1 gallon to 4 quarts, 1 quart to 2 pints, and then 1 pint to ounces, to 16 ounces. So that's the path that we're going to take. Okay, so here we go. So we have gallons on the bottom to quarts. And then we're going to get rid of quarts to pints. Getting rid of pints to ounces. So now we have to double check. Gallons goes away, quarts goes away, pints goes away, and what I have left is what I want. So now I know that I have it set up right. So do you see how we started with just 1 unit measure, and now we went to 2 unit measures, and now we're at 3 unit measures. So we just keep building. But if you stick with this process, you will never get these wrong. So 4 quarts to 1 gallon, 2 pints to 1 quart, and 16 ounces to 1 pint. So it's 102 times 4 times 2 times 16. So 13056. All right, so people on Zoom, you guys good? Am I going too fast? Yes, go ahead, Emma.
Sorry, I clicked the wrong button.
Oh, okay, you were doing the thumbs up.
Yeah.
Okay, thank you. Okay, good, Daniel. All right, so Kaylee, you're good. Jalen, Jade, Linus, you guys are all good? Yahira? Okay, thank you. All right. Okay, so let's kind of move on. Ounces to pounds. Let's do one more with the volume, and then we'll move forward. All right, so we're going ounces to pounds. So is that volume? Because we just did ounces and it was in volume, but what is pounds? It's weight. Yeah, it's weight. So at the bottom, you see mass and weight. Okay. And I like how they put this. This is at sea level at the equator on Earth. So the further you get away from the equator, your mass or your weight changes. And then when we go to the moon, then the mass really changes. Maybe I should. Okay, so we're going from ounces to pounds. So there is 1 unit of measure. 1 pound is the same as 16 ounces. So this is as weight, which is different than the 16 ounces as volume. Okay, so volume is how much it holds. Weight is how much mass there is, or how much, like you could think of it as how much is the gravity affecting the pull of gravity. All right, so we go 96 ounces over 1. And then ounces is what we're getting rid of, and we're looking for pounds. Let's cancel. Pounds is what I want. So I know I'm good to go. So 16 ounces to 1 pound. Okay, so when there's numbers on the bottom, you just multiply straight across. Multiply straight across. So it's 96 divided by 16. And we have 6 pounds. Okay. Now, again, just remember that all the answers to these are in the back of your packet. So I like to skip them so that you are forced to go look and you have more things to practice. All right, so days, here we go. We're going days to seconds. So this one is not on your reference chart, but we can come up with them fairly easily. So we have 1 day is the same as 24 hours. 1 hour is the same as 60 minutes. And 1 minute is the same as 60 seconds. Okay. So here we go. We're getting rid of days and going to hours. Getting rid of hours and going to minutes. Getting rid of minutes and going to seconds. So now I know I did it right. I have it set up correctly. So 24 hours in 1 day, 60 minutes in 1 hour, and 60 seconds in 1 minute. $259,200 seconds. Now, what's interesting is if you do this as your age, years, right? So if you have 1 year is 365 days, so you would add, if this was, 30 years, or let's see, how old are you guys? 22? So, oh my gosh, you're a baby. 17, how old are you? 24, okay. 32, okay. I'm not telling you. My birthday's coming up. All right, so if we did, let's just do 20, let's be an average. So if we do 20 years, I'm throwing this one in there. I want to see how many seconds I am, or a 20-year-old is. How many seconds have you been on this earth? So we're getting rid of years, going to days. Days to hours. Hours to minutes. Minutes to seconds. This is going to make you feel really old at 20 years old. Okay, so years goes away, days goes away, hours, minutes, and what's left is seconds. So this is going to make your head spin, especially in light of all those numbers that we talked about. So how many seconds is that? Million, yeah. That's the third section, right? Third section is million, so 630,720,000 seconds. That is a lot of seconds to live at 20 years old. Add 40 years to that, and that would be me. Double that. Okay, so now we're going to combine scientific notation with unit conversions. Okay, so scientific notation again is one number in front of the decimal, and then the exponent tells you how many times to move that decimal point. Okay, so because it's positive, we're going to make this a larger number. So we don't want to do that yet. And I'm going to show you how to use this on your calculator. So it's 1.98 times 10 to the 8th seconds over 1. So now we're using those same units of measure, and we're going to years. So seconds goes away to minutes. Minutes is going to go away to hours. hours to days. Days to years. And then I'll show you how to change the decimal into months. All right, so our seconds goes away, minutes goes away, hours goes away, days goes away, years is what we want. So 60 to 1, 60 to 1, 24-hour to 1 day, and 365 days to 1 year. Okay, so on your calculators, if you have the TI-30XS, right in the middle, there's third column over, third button down. You see it says X 10 to the end. You see that button? All right, so the way you use it is you're gonna go 1.98 and then hit that button. And it's raised to the 8th power. And then you're going to hit enter, and you can see it changes it, right? It moved that decimal 8 times. Okay, then you're going to divide by, and then hit parentheses, and then type in all those values, 60 times 60 times 24 times 365, and then close it, close the parentheses. So it's 6.365740741. So this is years. Okay, so we know it's going to be 6 years. And then to be able to change it to months, we're only going to just change this part. So 0.3657441. Notice I did not round it. And I'm going to go years to months. So remember, there are 12 months in 1 year. So we're just changing the partial. This is a partial year. So 1 year is 12 months. Okay. So sometimes you have to do this a couple times to get it to the right. Everyone get that? Is that the right calculation? So the first part? Yeah. Okay. So you're going to go 1.98 and then hit that times 10 to the n button and enter 8. And then make sure you hit enter. So 198 and a bunch of zeros. Okay. And then divided by, and then hit the parentheses, because we're dividing by all of that on the bottom. So 60 times 60 times 24 times 365, and then close the parentheses. Now I got 6.27. I wonder if I hit 7 instead of 8. Let me try it one more time. 1.98 into the 8. I divide. I got these new nails. And they're a little bit longer than I'm used to. So I may have hit that extra button. There it is. Okay, so you are right. So it's this is 0.278538813. And then we're going to change. So 0.278538813. We'll see if it's a big difference. 0.278538813 times 12. So it's 3.34 months. Is that right? Is that what you guys got? You went? Oh, okay. Yeah, it's a lot. But you can see if you set it up and you double check that you have it set up correctly, then the numbers just fall into place. You don't have to guess where the numbers go. And you don't have to guess if you have to get bigger or smaller or where do the numbers go, top or bottom. It's already set for you because you've already done your unit multipliers. So yeah, and then I rounded that second line, 0.34. So 6 years and 3 months, 3 1/3 months. All right, everyone good? Okay, so now we're going to add another layer. Okay, so before we set up the very first one with just over 1, right? Whatever they gave us, we put it over 1. Now they're saying we have inches per second. So what we're doing is we're looking at it in terms of time. Okay, and then we have miles per day. So it's the exact same idea, except for now, when you set up your 88 inches on top per 1 second. So now we have a unit of measure on the bottom that we have to get rid of. So we're going from inches per second to miles per day. Okay, so we're going to do this in 2 phases. The first phase, we're going to deal with inches to miles. So look at your unit of, or your reference sheet. Can we go directly from inches to miles? Or what path do you want to take? Perfect. Okay, so we're going to go inches to feet, and it's 12 inches to 1 foot. And then we're going to go, I'm writing this different now, aren't I? Let me write it the same as I've been doing, just so I don't cause confusion. So 12 inches equals 1 foot, and then 5,280 feet equals 1 mile. Okay, so we're doing the exact same thing. We're not worried about the seconds yet. We'll jump on that in a minute. So go ahead and set that one up. So we're getting rid of inches, changing it, excuse me, to feet. We're getting rid of feet and changing it to miles. Okay, so double check the first. Inches goes away, feet goes away. I have miles left. That's what I want. Okay. The second phase is we're changing seconds to days. So we're going seconds to days. Okay, so we have to do 60 seconds equals 1 minute. 1 minute, oops, sorry. 60 minutes equals 1 hour. 24 hours equals 1 day. And you can put those, since they're not on your reference sheet, you can put the days and hours and minutes on your reference sheet if you need it. If you don't need it, then don't add to the list. But if you need it, go ahead and write that on there. Okay, so here's the second phase. This was the first phase. Exactly what we've been doing. Now we have seconds is on the bottom. How can I get rid of seconds? Where does it need to go to be able to cross cancel? If it's on the bottom here and I want to get rid of it, where should it be on this one? On the top, yeah. So we're going seconds to minutes. And then I want to get rid of minutes, so it's going to go on top to hours. And then I want to get rid of hours and have days on the bottom. So you notice days is on the bottom. So when you cross cancel, seconds goes away, minutes goes away, hours goes away, and what's left is days on the bottom. And notice I have not put in one number. All I'm doing is I am setting up so that I know that I'm set up correctly. If you don't set it up first and you just try putting in numbers, it's going to get real confusing. All right, so here we go. 12 inches to 1 foot, 5,280 feet to 1 mile, 60 seconds to 1 minute, 60 minutes to 1 hour, and 24 hours in 1 day. Okay. So everything on top stays on top. So we have 88 times 60 times 60 times 24. And what stays on, or what's on the bottom stays on the bottom. So on the top, so double check my numbers with your calculator. Both numbers good? And then just do the division. So it's 120 miles per day. And that's the other reason why I circle what I'm changing it to, so that I can pick it up really easily at the end. I know exactly what unit of measure I'm working with. Right? So does that make sense? 88 inches per second is 120 miles a day. So when I go to San Antonio, down and back is 135 miles. No, 130 miles. So down and back is 88 inches per second, or 120 miles per day. All right, so now you can see it gets a little more confusing, right? So if you don't use that technique, you're going to get real confused. So that's why I start real adamant. Now, if this was a test question and your answer, you just had 120 miles a day, but you didn't show me how you set it up, I'd mark it wrong. Even though your answer's right, you're not showing me your work. So on the test, make sure that you have everything laid out. So practice it when you're doing your homework, practice that. Make sure you have everything laid out. All right, here we go. We're going first, just do units of measure first. Gallons to liters. So look at your reference sheet. And liters and gallons are both volume. So look in the volume. Very good. So there's 1 gallon is 3.785. I'm going to round it to that, liters. So set that up first. And it's per, so per always means division, per week. And it's 1 week. So the first thing we're going to get rid of is gallons. And we're changing it to liters. Oops. So 1 gallon to 3.785 liters. My gallons goes away, and what's left is my liters, so I'm good there. And now I'm going weeks to hours. So we haven't looked at weeks yet. So the unit of measure is, so we have 24 hours in 1 day, and we have 7 days is 1 week. So here's your path. So we're getting rid of the weeks. So that's going on top. And we're changing it to days. Getting rid of days, so it goes on top, and turning it into hours. So the number that's on the top stays on the top. And the numbers on the bottom stays on the bottom. And then you can calculate. And when you're doing doing these on your homework, I haven't been doing it. Go ahead and box in your answer. It just makes it easier. If it's on the line, then you're good. You don't have to box it in. But if it's like what we're doing now, where it's kind of just out there. Okay, so 272.1595 liters per hour. Sound good? Okay. Good time. All right. Oh no, you're good. Is that one okay? Mhm. All right, so I'm going to leave 16 alone. You guys can practice that on your own. All right, so now let's get into some word problems. So on number 17, it says if a certain model of Volkswagen gets 11.48 kilometers per liter in Europe, is this considered good gas mileage in the US? So if it's kilometers per liter, how do we find, or how do we measure gas in the US? Gallons per what? Miles per gallon. Good. Miles per gallon. Do you guys know that that's what that MPG stands for? Miles per gallon. Okay, so that's what we're looking for, is miles per gallon. So we're going to change kilometers to 1 liter. So we're going to change kilometers to miles. So look at your unit conversion. So which one you're going to use? Okay. So 1 mile equals 1 point. We're going to go ahead and round this because this is the unit of measure. And this is the honest to God truth. When we were in Ireland, I use this all the time because we're going driving down the road and the speedometer. And if you've never driven on the left side, it blows your mind. Like your brain is so spun out. It took 3 or 4 days before we got used to driving it. But you're driving along and you look down at the speedometer and you're going 120. And so then I had to go, oh, that's only 120 and 1.61, and I had to change it. So you actually use it, but it does spin you out, man. I think I ran up on the sidewalk a couple times when my husband was driving. He would brush the shrubs on the side. The roads are so narrow. All right, so here we go. Kilometers goes away. Miles is what I want. So it's 1.61 kilometers to 1 mile. Now we're going to go liters to gallons. So we're looking at volume. So thank goodness they gave us one. So 1 gallon to 3.785 liters. 1 gallon equals 3.785. So this is gonna go away. And gallons is what we want on the bottom. So liters goes away, gallons is what we want on the bottom. It's miles per. So is that pretty good gas mileage? That's not bad. My car gets 34, which I love, and it's not electric, which I absolutely love. All right, everyone good? No questions so far? Feel like you got it? Okay, here we go. Now here's some applications. We already did that. Okay, here we go. Number 19. Mary is painting a rectangular wall that measures 3 meters by 7 meters. She wants to find the area of the wall in square meters. So with these, you can always draw a picture. There is nothing wrong with drawing a picture. If you are a visual person, I would highly recommend it. So it's 3 meters by 7 meters. And area of a rectangle is length times width. So we're going to go 3 meters times 7 meters. So we have 21, and don't forget the unit of measure, meters squared. So we want 21 meters squared to go to feet squared. So square feet, feet squared, both of them, it's exactly the same thing. So this one is just over 1. So the only time you'll ever have anything on the bottom, a unit of measure on the bottom, is if it says per something. So we have squared. So remember, you got to do it twice. Oh, I guess we need to look and see what unit of measure we're going to use. So we have, okay, we have 1 foot is the same as 0.3048 meters. So we're good there. So because we have 2 here, we have to repeat it. So I'm getting rid of 2 of them. So with this, you can do the division, just make sure that you put parentheses around the 0.3048 and then close the parentheses. I actually use this a lot. My husband's an electrician, and he'll call me and go, okay, how do I figure out how many cubic yards of cement when he has a hole that's like a half a foot by 3 feet deep? So another example of using units, unit conversions. Okay. At a given point in its orbit, the moon is 2.4 times 10 to the fifth miles from the Earth. How long does it take light from a source on the Earth to reach a reflector on the moon and return? And speed of light is 3.0 times 10 to the 8th meters per second. So we're going from miles to meters. So miles to meters. So this one gives you some choices. So you can either go miles to kilometers and then kilometers to meters, or you can go miles to feet and then feet to meters. Since we did it the other way, I'm gonna go, you guys choose which way you want to go. I'm gonna do it miles to kilometers and then kilometers to meters, just so you can see how it's set up. So we have 1 mile is the same as 1.61 kilometers. And then what do you remember about kilometers to meters? How many meters in a kilometer? Good. So 1,000 meters to 1 kilometer. So I'm just going to do this part first. So meters goes away, kilometers goes away, meters is miles goes away, excuse me. Kilometers goes away, so I have meters. So 1.61 to 1 mile, 1,000 meters to 1 kilometer. Okay. So using that scientific notation button really is quite nice. So 2.4 times 10 to the fifth, and then hit enter. Make sure you hit enter because otherwise the cursor is up in the exponent key. And so it'll probably give you an error if you don't hit enter. And then that times 1.61 times 1,000. So this is meters. I want to double check the answer, make sure I'm doing this right. So it says in the back of the book that it's 2.58 seconds. And I'm getting 1.28 seconds. So either I don't have enough decimals. Miles goes away to kilometers. Kilometers goes away to meters. Three, six, 4, 3. Anyone have any ideas? Because it should just be a division. Should just be this divided by 3 times 10 to the 8th. Let me try this. 3.8464. All right. I'm going to put a question mark by this. I don't know why the answer in the back says 2.58, but that should be how it's done because this is meters per second. So every meter or speed of light is going 3 times 10 to the 8th. So 3 with 8 zeros meters every second. So when you divide that, that would be how you would get how many seconds. So I will double check that. So I'll come back to that one. Because my answer that I'm getting is not the same as the answer in the back of the book. Is anyone getting a different answer? 1 point something? 1.28? Is that what you got? Okay. So it could be an error in the book too. All right. Let's see, where do I want to go? We'll just do a couple more just to double check. Okay, so I'm going to give you 2 to do, and then we'll come back. So I want you to do them on your own. I'm not going to show you anything. You do them, get an answer, and then we'll come back and double check your answers. So do number 23. Steve can run a mile in 12 minutes. How many feet can he run per second? And then 24, Matt fills his bathtub at a rate of 0.4 liters per second. Brooke fills her bathtub at a rate of 25 quarts per minute. Which bathtub fills faster? So that one you have to decide, are you going to go change the quarts per minute to liters per second or liters per second to quarts per minute? Whichever way you go, you have to have the same units of measure to compare. So 23 and 24. So go ahead. Daniel, the questions, oh, you got it? So Nathan, we're doing number 23 and 24. And then we'll do them together. I just figured it out. And you checked the answer in the back. Okay, good. Okay. And it may be you just took a different path. You know, if your answer is gotcha. Yeah. Okay. Okay. All right. So back to number 20. So dumb. Sometimes you have to read the question the second time. So it's how long does it take to go from the Earth to reach a reflector on the moon and return? So it takes 1.28 meters per second to go from the Earth to the reflector. Then you multiply by 2 and you get 2.58 meters per second to go down and back. So we did it right. We absolutely did it right. I just didn't catch that detail. Okay, here we go. So number 23 So give me some of your answers. Let's see what your answers are. If anyone has the same or different, or someone give me an answer. 7.33 feet per second. Okay. All right, so here we go. So this one, you have to be careful how it's set up. So Steve can run a mile in 12 minutes. So you could set it up this way, 1 mile to 12 minutes, right? It says a mile in 12 minutes. That's fine. But when you look at what we're looking for feet per second. So feet per second. So what I want you to do is I want you to notice, how is it set up? Are you writing it 1 mile to minutes, or are you writing it 12 minutes per 1 mile? So you want to notice, what are we looking for here? We're looking for the distance over time. So we want to use this one, distance over time. And that way your answer will be set up correctly. So here we go. So we're going 1 mile to 12 minutes. Okay, so this is the first time that we'll have a value on the bottom, which is okay. We know how to work with values on the bottom. All we're doing is we're changing the unit of measure. So we're getting rid of miles first, and we're taking it to feet. So miles goes away, feet is what I want. So it's 5,280 feet to 1 mile. And then we're going to go from minutes to seconds. So again, the minutes is on the bottom, so I have to write it on top so I can cancel it. And what I want is seconds on the bottom. And it's 60 to 1. Okay, so multiply straight across, 5,280 times 1 times 1, and 12 times 60. So that gets at 7.33 feet per second. Okay?
Is it okay if you separate it? Because what I did was I did the distance part first, and then I did the mile, or the time part second, and then
Then combine them.
Is that okay, or would you prefer?
My only hesitation, so the question was, can you do the miles first and then do so tell me if this is how you did it. 1 mile, 12 minutes, and then you did the minute here and second here. Is that what you did? Where you separated the two?
I think you like the distance portion first.
Okay.
And then I did like 1 mile, and then that's what it's like.
Yeah, because I've seen it done that way. And the only reason why I hesitate is because it can get confusing, because it's like, what number did you end up with and what number did you okay, so how did you go from here to here? What did you do?
I divided the top number that I got.
Okay, so the only problem with that is, what if you flipped it? Then it would be a different answer.
Okay.
Right? So I prefer if you just go straight, use all your room and just do it straight, because then you can see, okay, I'm getting rid of miles or minutes, sorry, and I have seconds. Okay.
Thank you.
All right. So everyone good on that one? Okay, next one. So this one you're comparing measures. So Math fills his bathtub at a rate of 0.4 liters per second. Brooke fills her at 25 quarts per minute. So this one the only way that you can compare is you have to compare apples to apples. So you either have to compare liters to liters or quarts with quarts. So it doesn't matter which way you go. I'll do it both ways. You'll end up with the exact same answer. So here we go. So if I go from liters per second to quarts per minute, okay, that's one way to go. Or you can go quarts per minute to liters per second. So either way works. So I'll do it both ways. So if I go liters per second, so 0.4 liters per 1 second. So, and I'm going to quarts. So liters to quarts. I'm going to go quarts to gallons, gallons to liters. So write it up here. So 4 quarts equals 1 gallon. And then 1 gallon equals 3.785 liters. Okay, so liters to gallons. And then gallons to quarts. And then I'm going seconds to minutes. So seconds is on top, so I'm going to write it, or it's on to bottom to top, so I can cancel. Okay, so double check. Liters goes away, gallons goes away, quarts is what I want. Seconds goes away, and minutes is what I want. So it is 1 gallon to 3.785 liters, 4 quarts to 1 gallon, and then 60 seconds to 1 minute. So this ends up being, so 0.4 times 4 times 60 over 3.785. And this ends up being 25.36 quarts per minute. So you can see his is faster, right? 25.36 is more than 25 quarts. So Matt's is better. Okay. No, because you're just comparing. You're figuring out which one is filling up faster. So 25.36 is higher than 25. So Matt's is better. So if you went the other way, you would go 25 quarts per minute. And we're getting rid of quarts to gallons, getting rid of gallons to liters. So I'm using the exact same units of measure. And then I'm getting rid of minutes to seconds. So quarts, gallons goes away, liters is what I want, minutes goes away, and seconds is what I want. So I'm going in the opposite direction. So we have 1 gallon, 4 quarts, 3.785 liters to 1 gallon, and 1 minute to 60 seconds. So it's 25 times 3.785 over 4 times 60. And when I do that, I get 0.394 liters per second. So this, yeah. So it doesn't matter which way you go. The idea is you have to get the same unit of measure. So either you change the liters per second to quarts, or you change the quarts to liters, and then you can see which one is faster. Okay. Okay, good. So Matt's is the better one. All right, we're going to stop there. So real quick, your homework is a little bit on the schedule. It looks a little bit different. I really had to look at it to make sure I got it right. So for Friday, you have 2 homeworks. Homework 5, which is what we just did, and then homework 6 we'll do on Thursday, order of operations and linear equations. So those 2 are going to be due Friday. And then your quizzes, if you have 2 quizzes, the quiz 3 is going to be due on 9/16. So that's Monday. And these are online, these are in Canvas. And quiz 4 is due 9/18. Okay, so it looks like you have 4 things due this week. You do not. You have 2 things due, and then the quizzes is on the 16th and then the 18th. So it kind of spreads out. So I tried to highlight that a little bit. And it should show up in your Canvas on what assignments are due. Okay? All right, guys, practice, practice, practice. For those of you going into medical, you have to have the unit measures, the dimensional analysis down pat. So I will see you on Thursday.